Does this work? Yeah, there we go. Cool, okay. The way we're going to just structure this firstly is we're just going to give the panellists a couple of minutes, first of all, to introduce themselves. And 3 of them also have a bit of slides as well that they'll just take us through in the introduction. After that, we'll crack on into some panel questions, and then we'll also take questions from the floor or Slido as well after that. So, first up, Grant, are you able to just take us through a bit of an intro? You can do it here or at the lectern, up to you.
Have we got the slides ready to go? Okay, so Grant Burke from NZIGE. So when we think about scale in the gas industry, this is what comes into our mind. Big gas fields, high pressure pipelines, all connected together, units of measure of petajoules. Am I clicking through it, or are they doing it for me?
Yep.
So this is what the gas industry in New Zealand looked like before 1970, before we found Kapuni and Maui. So none of them were connected. It was a viable gas industry. This was a collection of small undertakings. If we look at Masterton, which was left off the natural gas grid, that was a 30 terajoule undertaking. So I think there's a lesson here for biogas that lots of small things can add up to a big thing, and they don't necessarily need to be connected together. The first and last Towns Gas company was Dunedin. They ended up with a project that looked like this. It didn't work that successfully, but the idea was wonderful. So they took gas off the tip, they cleaned it up a bit, they put it into a big gas holder in the middle of town next to Carisbrook. They put it through a Venturi and mixed its calorific value down to what the old Towns gas had been. To back that up, they did the same with LPG. They took LPG, mixed its calorific value down so they could use that as a peak shaver. And I think there's a lesson in there for the biogas industry as well. A bit closer to my day job at Rinnai. The appliance on the left, you can go down to Plumbing World and buy one if you want. That has a combustion system similar to your car, where if you vary the calorific value of gas going into it within a range, it will adjust the gas-air ratio to keep burning beautifully. If you go to a completely different gas type, you tell it with your phone that you're on a different gas type and away you go. In terms of scale, we make those by the 1,000. The white ones on your house at the moment, we make by the million worldwide. And so obviously in order to bring the more expensive technology into the white ones on your wall, we need scale and more sales. So there are a few thoughts from me on how I see scale.
Thanks, Grant. Right, next up, Trevor.
Slide. There we go. Kia ora tātou, I'm Trevor Stuthridge, CEO for Cetogenics. So we are a Rotorua-based deep tech waste-to-X technology company. And our platform technology is CetoBoost. What CetoBoost does in a modular system, it uses temperature, air and pressure to precisely deconstruct organic waste, a broad range of waste, municipal, agricultural and industrial, into renewable natural gas, green ammonia, biogenic carbon dioxide and clean phosphorus. And then we discharge clean water back into the environment. So over 99% of the organic material is converted into high-value material. Each module does 25,000 tonnes. That's equivalent to the biosolids or sewage output from Tauranga, so a reasonable city in New Zealand. And we generate 40% more gas than a standard AD system because of our use of the digestate and the non-degradable materials. Some of the advantages of our technology, we eliminate 100% of the contaminants like microplastics as part of the process. As a modular system, we have a small footprint for retrofitting. Given the high cost of power in New Zealand, we have a positive energy return, so we generate 5 to 10 kilowatt hours of energy out for every kilowatt hour of electricity we use in the process. And if you combine CapEx and OpEx, we are 50% lower than our competitors. Here in New Zealand, we're working closely with EcoGas, pleased to have a partnership with EcoGas, and we'll be putting our pilot plant on their Reparoa site shortly for long-term trials. Also working with Trinity Lands, who own 23 dairy farms in the South Waikato, and with support from Ariake and BPO in Hamilton, we've been developing the concept of a Ceto hub. This addresses the issue of manure availability in New Zealand because only 7% of manure is collected on the farms because of our pasture systems and seasonality of our dairy systems, etc. So Ceto hub takes multiple feedstocks throughout the year onto one single farm operation. We'll generate 77,000 gigajoules of gas from that process. The farmer is very pleased because they will be independent of synthetic fertilisers, so we'll recover enough ammonia and phosphorus for them not to buy any synthetic fertilisers. We have a positive or negative carbon footprint, depending on how you calculate it. This farm currently emits 5,000 tonnes a year of greenhouse gases, and with the offsets of the gas production and fertiliser use, they would be emitting a minus 1,000 greenhouse gas per tonne per year emission. And they're very pleased with the economics, 18% IRR, 5.4 year payback. That's for the entire system, including the AD system. So they have to build an AD, of course. And then we've done our mapping. I'd love to talk to Ika about mapping. We've mapped quite a lot of the feedstocks around the country, and we have some hot spots. We've calculated just 50 of these CETO hubs around the country would capture over 80% of our dairy waste and generate 4 petajoules of waste material, renewable natural gas. Internationally, we're working with PepsiCo around food and beverage opportunities, which can also be translated back into the New Zealand food and beverage sector and other industries. And we're working with Anglian Water, Severn Trent and Thames Water in the UK, de-risking the technology for applications in wastewater treatment and sewage processing. Thanks very much.
Thank you. Dan, you're up, mate.
Kia ora, Dan Gnaut. I'm the GM of Research and Insights at Araake. Araake is New Zealand's National Energy Innovation Centre, and our purpose is to accelerate the commercialisation of energy innovation. So we are a bridging organisation. Our focus is usually on early stage development, so organisations like Cetogenics that have something that is coming out of the lab ready for demonstration and pilot. That area where we often call the valley of death with new innovations, where there isn't a large access to capital to really get something moving. So we are an accelerator organisation. But we do other things around that. So we do spend time in activating new industries. So really excited about Ika's announcement today and the work that they're going to be doing, because we've been looking at the regional opportunity in Taranaki and working with Scion to identify pathways for the different industry participants to leverage this opportunity. And we also do a lot of advocacy work on the other side of this trough as well, when we're working with regulators to make these innovations understood and the barriers recognised as well by government. So, kia ora.
Thanks, Dan. And last but not least, Paul. Thank you.
I thought I may as well stand up.
Might as well.
I haven't got any slides, so I feel a little bit lazy, but here we go. I'm Paul Bennett. I'm from Scion, and Scion is now a group of within the Biosciences Bioeconomy Science Institute. So we've now merged with Plant and Food, Ag Research and Landcare. That brings a hell of a lot of capabilities into Scion. We were predominantly focused on wood and forestry, but now we're looking at all those other resources as well. And so I'm also a board member of the Bioenergy Association, and I represent New Zealand on the executive committee of the International Energy Agency Bioenergy Group. In fact, I was chair and vice chair of that for a period of about 5 years. Within Scion, we focus on all things bioenergy. We look at feedstocks, we look at biogas, we look at solid fuels, and we look at liquid fuels. We can't cover everything, but we really choose where we focus. And so biogas is one of the key areas we focus. We focus on marine fuels as well, and we focus on feedstock. They're the main areas. On biogas, we've got a long history with EcoGas or EcoStop. Before that, we worked with them. We put a 1.5 cubic meter digester on their sites. We monitored it remotely, controlled it remotely, and we're testing a whole range of different feedstocks through that, testing how far we could push the digester before it fell over, or the bugs fell over. So bit of a history with ecogas. Now we're really focusing around dark fermentation as a way of increasing yields from biogas. We're also looking at energy systems modelling and looking at where the feedstocks arise, how you can convert those feedstocks into useful energy products, and where the demand centres are. So it's really an optimisation tool around pulling all those different things together. And as Dan said, that's what we're working on with Araaki, focused on the Taranaki region. I'll leave it there. Thank you.
Thanks, Paul. All right, we'll get into the moderated discussion now. So first question, and I might direct this at you, Paul, to kick it off, and that is, how can technology enable the broader uptake of anaerobic digestion in New Zealand?
I think first of all, we just need to deploy the technology that we've got. It works. We need to really understand the feedstocks, and it's great that ECA are doing a piece of work there, and certainly we'd like to talk to you about that. Really understand the feedstocks, the nature of those feedstocks, where they are, what's the seasonality, and how we can bring it together into a single plant. And then in terms of technology, we need to look at what's happening around the world. As I said, IEA Bioenergy is a fantastic group. We learn there's 26 countries involved in that, ranging from those big behemoths that are working in the energy sector, like the US, Brazil, Germany, and we can learn from what they have been doing, both in terms of technology development and technology deployment, and even policy landscapes, what has worked, what hasn't worked for them. So you know, we don't have to reinvent the wheel. We know what technology we've got that works. Let's have a look what other people are doing and what technology is being deployed in other countries.
Fantastic, thank you. Do you have any thoughts on that, Grant?
Yes, I would agree that rolling out the technology we have is viable. The big issue I see where we need to work on the technology is cleaning the gas up so that we can use it in our normal appliances. That's, to me, seems to be the big expensive bit that we need to get the cost down to 10 cents in the dollar of what we've got now. So that's really the area, I think, for future research and development, to make the scale sensible for New Zealand.
I'll probably show my commerce background here, but the cost of gas would be a result of the fixed costs and variable costs going through volume. So Trevor, you've probably got some ideas around how to get gas a bit cheaper while using technology.
Yeah, with shameless bias towards what we're doing, because it meets that sort of need. So we need to increase gas yields from the material, because if you're paying gate fees, you need to maximise the yield. So that really, from our perspective, looking at the European example, means better use of the digestate. If you look at the European example as well, there's high likelihood we'll encounter contaminants in the waste material, and so we will need to deal with those contaminants if that material is going to be redispersed onto agricultural land. That's a cost thing, and then we do have high electricity costs here in New Zealand for AD systems, and we have to sort of find a way to address that, either by potentially dropping electricity costs, which is unlikely, or perhaps increasing the gas price. So in our CEDA Hub model, we know that we have to have a gate fee to make it work, but actually it only has to be another $8 a gigajoule for the renewable natural gas or biomethane, and then we don't need a gate fee. And that we still would have gate fees because you want to make people pay for the privilege, but it just means more profit to the bottom line for the operators.
Thanks. Just while you're holding that mic, how can we ensure, and this probably carries on from a theme that was coming through a previous panel discussion, you say, if I recall correctly, and that's around prioritisation of waste and energy and getting it to the right spots it needs to be. And so how can we ensure that waste streams match their best value end product and accelerate the steady state for developing a marketplace?
I guess our philosophy, and I think it's a good one, is that the best way to optimise waste utilisation is to make lots of money from it, like EcoGas is trying to do, or is doing, hopefully. So that means value propositions that where you're not saving costs, but you're actually generating revenues in the economy, economic value from the waste material, and it truly becomes a resource, not a sort of a secondary focus. So I think the focus for New Zealand is we have different challenges from Europe and North America with respect to biogas. It's not the technology itself is pretty standard, but the circumstances are different here. We have highly seasonal feedstock supplies, for example. We have to address that. The dairy sector shuts down in the winter, so if you're relying on agriculture manures, then they're not here. Most of the time, the cows live on the pasture. So we're not collecting the manure. I mean, the AD industry in Europe was created because they had mountains of manure. We don't. It was built out of an imperative to get rid of the manure. Adding value came later. So I think we have unique circumstances, and I think the fundamental question that will come out of later in a future panel today is you need policy and regulatory certainty. Not so much about gas prices being fixed or anything, but actually more, are you going to ensure that if I do this capital investment, that my model around waste as a feedstock going to a renewable product will be maintained and sustained? And then you're not going to change the rules and go, we're all back to landfill now, or something like that. Yeah.
Cool, thank you. Dan, do you have any thoughts around that with your work you've been doing with Simon and Araki?
So it started this morning around that visibility of the opportunity. I think that's still something that is relatively new to New Zealand. There have been a number of studies done at high level as discussed, but not always at that detailed level. Also then the understanding amongst industry participants around what needs to be shared. I think there's, in doing the investigation in Taranaki, there's a lot of interest, but even with that interest and kind of openness, the information is not necessarily easy to find. So navigating the opportunity is still sometimes a bit of a challenge to know what's where and how to make use of it. And then, as discussed by Trevor, recognising that this is a long-term investment. This is a long-term use of land, use of energy. So when we're looking at feedstocks and where to put these types of plants, the participants involved need to be aware that the use of that land needs to be considered in a much longer time frame than perhaps is normally done. Yeah.
Cool, thanks mate. Paul, do you have any further thoughts on that?
Yeah, I think, as Trevor said, the economics drive this. I mean, you talked about the best use. There's lots of ways of defining best, but I think for this, it's economics. In terms of technology development and deployment, I think one of the big gaps I see is that follow-on investment. So we're great in New Zealand coming up with some new ideas and actually getting a bit of seed funding into those new ideas. Where we really fall over is that follow-on, the sort of $10 to $20 million worth of investment to really scale up the technologies, and that's something that we need to get better at.
Cool, fantastic. Right, barriers to investment, and what do you see them being? And how can we make investment in biomethane production easier and more accessible? Who wants to kick that one off first? Good on you, Dan.
From the work we're doing in Taranaki, there's a willingness. There isn't necessarily always the capital in kind of one place. That sometimes the barrier is getting those partnerships right. These are new partnerships that are needed amongst different participants in the sector that might not have existed beforehand. And without that kind of strong sense of trust and understanding amongst those partnerships, it's quite tricky to then move forward to a decision in a collective way. So there is a social barrier alongside the capital kind of risk.
Cool. Have you got any thoughts on that, Trevor?
I add on to that. I guess the waste management industry that was touched on yesterday is quite conservative and arguably somewhat monopolistic. And so the real challenge, I get here in Wellington, I come from Rotorua, but I get really frustrated to watch the project at Moa Point. They're spending hundreds of millions of dollars to dry biosolids and presumably landfill it or do something, but they're not adding value to it. That's happening. Well, Watercare is looking to do the same, build incinerators This is not the way to add value to this material, and it's just not economically smart. I just came back from Singapore. They're a similar population to New Zealand. Every 3 years, they're spending $1 billion on a million tonne a year incinerator. It makes no sense at all to be doing that sort of thing, but we tend to default to that. So I think the barrier, in my sense, is actually mostly psychological and emotional. Europe, the rest of the world has done this many times. Germany has 9,000 anaerobic digesters. It's not a big stretch. We have, Ecogas and a few others scattered around. It's not a big stretch for us to do this. We just need to have the courage to do it. And to Paul's point, it needs to be economically viable. People will always do stuff if they can make money doing it. And it's a good investment. That's what we've got to encourage. Not mandate it or force it to happen. Offer a value proposition where they make lots of money and defossilise our energy system, and it should happen. But New Zealand has a terrible avoiding the bleeding obvious psychology at times, or wanting to be first to be third, and I think we just need to wake up and get on with it and stop mucking about. It's mostly in our heads, in my opinion.
Powerful stuff. Anyone else want to add to that? No? Yeah, have a own, yeah.
So just at a personal level, I attended electrifying Aotearoa in Grey Lynn, and presented there, which was confirmed my prejudices. I live in Devonport, so it's not much different. From the other end, I would be personally prepared, and there's lots of other people. And I know my residential gas use is a drop in the bucket, and so no one's interested in me. But I would be prepared to pay double my current gas rate to be able to get onto Power Switch and buy zero carbon gas. And all those people in Grey Lynn would have as well. But there's no mechanism for me to be able to do that because it's chasing larger loads. Yes, my 10 cents worth on that one.
No, great. Thank you, Grant. Okay, last thing we'll just cover off in this moderated discussion, and because I do want to allow lots of time for questions, we've got quite a few, and please do keep them coming. So I'll probably be keen to hear from each one of you, to be honest, on this one, and that is, what's the most valuable thing we can do today to enable the future energy system with biomethane contributing at scale in the future?
To the gas industry as a whole, and this is slightly left field, is legislate, as was done, I think, in the 1990s, to split gas away from electricity so that we compete, not be constrained by it, be constrained by ownership by electricity organisations.
Thanks, Grant. Dan?
So 2 things. The first thing is start. I think most people in this room are starting or already in the thick of it. But like that chart I showed, where there is generally a big trough to starting something new, it is prepare. You need a lot of gumption to get something over the line in this country. The ones that have made it happen are exceptional, and to get to a point where we are scaling and moving at pace, we need to prepare that this is a slog initially, and then things will get much more exciting after that. So yeah.
Cheers, mate.
I think we need to be positive about this. I think we need to celebrate our successes. New Zealand does tend to be quite risk averse, but we have had some successes. We need to continue those. Ecogas has been fantastic. See all the accolades Ecogas have got. We need to be singing about them and Cetogenics, but we really need to get more great examples on the ground. And the more examples, the more Ecogas plants, the more Cetogenic plants we get on the ground, the more normal it becomes, the more accepted it will be.
Thanks. And Trevor?
I mean, our discussions with end users like the energy providers and that, the large industry players would suggest they're all quite committed to doing renewable natural gas. They see the value in it. partly for consumer demand at the other end of their value chain, but also because it just makes sense to do it if they also make a lot of waste. So I don't think there's any issue around mandating as such. I think common sense should play a role here, but I do think access to good quality capital investment funding is critical. That encourages, no one's saying subsidies or giving away money, but finding good loan equity that allows these projects to stand up and go forward, and then we will, much like the rest of the world, we'll hit a critical mass and it'll just become the new normal that we do AD biogas with our waste materials, and we'll outcompete the landfilling requirements and so forth from an economic perspective. So I think, yeah, it's really around capital investment and allowing an acceleration. As Paul said, the technology is already out there. We just have to cut and paste it to a point, acknowledging that there are some nuances in New Zealand we'll have to address, which isn't the same as somewhere else. But I think I'd note yesterday in the presentation, no other economy in the world has ever created the biogas industry without substantial support of some sort. And we can be very proud that we're market-driven and free market and we don't need any of that stuff. There's a reason why they've done it over there. It's because they have encouraged people to do it and provide the right incentives to do it properly.
Thanks. Cool, okay, just to kind of summarise that moderated discussion. So, starting back with the technology, Paul, it sounds like we've kind of got the tech we need, noting that there are some exciting things on the radar with cetogenic and potential bugs and things like that, but all we need to do is really crack on and do it. And then, sorry.
First step, yeah.
First step.
Whilst continuing to develop new technologies that will increase the yields and hopefully reduce the unit costs.
Okay. And then there's a bit around feedstock there too, isn't it? So I think it's a constant thing we've been hearing here, is it's all about feedstock, and everybody that's developing biogas or biomethane plants know that it is all about feedstock. And so there's some positive signs there, I think, on the horizon as well. Okay. We'll crack on into some Q&A, because there are quite a few questions. It's good. You guys are popular. Okay. This is positive stuff, guys. The cetogenic plant sounds amazing. What stage of development is it at? What would be the smallest viable scale?
Well, appreciate the amazing comment. Yeah, our full scale 25,000 tonne will do 3,000 litres an hour. Our current prototype does 100 litres an hour, and the next one will do 500 litres an hour. We're not really concerned about scale up in terms of the tech. It's quite scalable, and in fact, so we can do smaller, but again, volume makes a difference. But we have pivoted into that modular system because it's a short sales cycle, plug and play, not disruptive. We don't have to modify the AD at all. So yeah, we're currently at what we would call technology readiness 7, and we have projects lined up with Ecogas, with Trinity Lands, PepsiCo, Anglian Water and others around the world. So we're about 18 months away from first commercial sale.
Fantastic. Here's one that's close to my heart as well, being a Taranaki resident, and it's probably aimed at you, Dan. Will the Taranaki region study also look at the economic impact for the region?
It's not the focus to look at the economic impact for the region, but to make, if the options identified and pathways chosen by the stakeholders is feasible, then it will make a substantial economic impact to the region.
And the model that we're deploying will also be able to get regional GDP out of it, number of jobs, all those sort of things, CO2 benefits. So we'll be able to pull all that information out of the model.
Fantastic. Yeah. For those in the room, probably pretty familiar when it comes to the Taranaki economy and the decline in conventional oil and gas. Economic impact is always off top of mind for us at the moment. Cool. Well, Trevor, back to you, but you've kind of already answered it, but there's a little tag-on bit to there. Do you have a reference project to visit? So I think they're going to swing by Sydney, touch the bubble, and come to you in Rotorua, probably, is it?
Yeah, so we have a working prototype on our site at Sion, but the goal of the EcoGas project, the partnership there, is that we can deploy it in real world situation and run it. We won't be running it online with EcoGas, we're running it offline, but we do like all the photographs that EcoGas gets taken, so we'll be able to photobomb as well with others who visit. But it's more around, again, very conservative industry. You may have an interesting or, quote, amazing technology, but until they see it in the real world, running under real world conditions, it's very hard to get them compelled. So yeah, we will have one, hopefully very soon in Reparoa.
Good stuff, thank you. Look, whoever grabs this one first can answer it. Many municipal wastewater treatment plants see biosolids digestate as problematic due to restrictions on disposal. To encourage increased co-digestion, how do we resolve this issue?
I can speak for the UK industry. It was very straightforward. They banned it. So they banned digestate onto land. Well, they are in the process of banning digestate on land, and that's got the industry very scared. And we speak to Watercare and others. Similar fears is that if they ban land application or land filling of this material, what do they do with it? And right now, the default is a $1 billion incinerator. Which is hideously expensive and ironically requires lots and lots of natural gas to dry the material before you can burn it. So incineration is the default of the wastewater treatment industry at this point after land application, and they're dead scared of that because it only takes one NIMBY default, or it takes someone saying we will ban your incinerators because of air emissions, and then they've got billions of dollars of stranded assets sitting at the wastewater treatment plants and still have a digestate issue.
We are also working with innovators trying to solve that issue, but I can't say what they are just yet. But yes, there are companies in New Zealand who are working with some of that challenge.
What a tease.
Cool solution.
Sounds good. All right, we'll keep an eye on that. Rightio. What is the current max yield for available biogas cleaning or upgrading technology, and what are the key limitations to increase the yield? I could probably take that first part. In terms of upgrading capacity, the sky's the limit as long as you can afford it. I mean, there are some plants overseas that are doing upwards of a petajoule, and Jared Irvine, is he still here? There he is. He's doing some big plants. He'll be able to fill you in about if there's a ceiling on that. But potentially, you guys are best placed to comment on what are the key limitations to increase the yield of biogas production.
I'm biased, but basically you utilise the 50% of material that comes out the back end as digestate. So that's wasted yield, basically. And the bugs, as Elspeth, I think, spoke out yesterday, the bugs can only do so much, and then all the fibres and that come back out the back end. So find a use for the digestate, and that's 40 to 60% more gas coming straight out of it, and it solves the other issue.
Thanks. Is there domestic-sized technology for household to produce biogas off the grid, and is it restricted by any regulations?
There's no warranty in our appliances if you do that. And yes, it is restricted by regulation. You need to clean it up to meet the natural gas specification that requires this $500,000 piece of gear. So that's why we need to solve that problem.
That's if you were to hook it into your conventional gas appliances, right? But certainly if you jump on AliExpress, you can find a backyard AD kit, and it'll come with a free stove where you could boil some water on it. So it is an option for avid composters.
I was going to say there's quite a lot of those units in parts of Southeast Asia, people having their own mini digester just outside the back door.
Yeah, absolutely. So you can certainly combust raw biogas. It's just doesn't have much calorific value, but you can boil a jug with it.
Yeah, so with caution, I don't know if we've got any plumbers and gas fitters here, but you won't get them to certify your installation, and your insurance company will be pretty interested after you've had an accident. So in practical terms, it's, in the field out the back of your farm, go for your life, not much is going to go wrong. But in your apartment in Newton, maybe not.
Thank you. Don't listen to me. For Paul, you mentioned you have some information about feedstock locations and demand hotspots. How can we access this information?
So as I said previously, we were really focused on wood and woody biomass. So that's what we've got all our information on. We are now working with Araki in the Taranaki region to try and pull together a picture of all the waste arisings around the region, where it is, what's the nature of it, how do we agglomerate it, how do we convert it into some useful energy products. So that is work that's ongoing at the moment within this collaboration with Araki.
Okay, and will that information be publicly available? Yep. Is there a time on that?
We're about 6 months into the project, and so we've started talking to stakeholders in the region. The project is, at the moment, is due to finish within 6 months, but we'll have to see where we get to.
Nice one. Thank you. How is it possible to make biomethane portable and the logistics of transporting it to end consumers? Right, that sounds like a gas engineer's question.
Bit challenging. At a practical level, obviously at large scale, it could be done in the same way as LNG is done. At a small scale, if we think back to the CNG industry that you want to crack into again, the CNG cylinder in the back of your car would have run your house, and I'm trying to remember now, for a couple of weeks. So it's a little bit of a challenge.
As Grant said, it's all around scale, but there are parts of the world, I think Sweden and parts of Germany, that are using liquid biomethane, so an equivalent of LNG, as a truck fuel.
Yeah. But I guess once you've cleaned that biogas into a biomethane product, which is pipeline specification, you would just compress it like any CNG and could be transported around. Yeah. And firing up a Ford Falcon. Right. How can we build 80 feedstock supply agreements to entice large feedstock suppliers who are hesitant to sign up for long terms and want to keep their options open? Dunno.
It's the fundamental problem. The gas off-takers are quite happy, I think it'd be fair to say, to take a 20 or 30-year off-take agreement as a rule, or long-term. But on the front end, yeah, the feedstock is really challenging because there might be something better along the way. So it's really hard to get a long-term agreement for feedstock.
But those feedstock providers might also be energy users, so you could almost put a tolling agreement in place.
Trevor, can you comment on your learnings getting a pilot trial over the line with EcoGas?
That part was easy, I would have to say. We simply got in touch with Elspeth and Andy Bedford and came and visited and said, would you mind if we plonked it down here? And they said, yeah, that sounds fine, just over here. So that was quite fine. Probably, in all honesty, to say it's a non-paid trial, that makes it a lot easier. So we'll do it off our costs, which is certainly appropriate, I think, at this stage. But no, I think we've sufficiently de-risked our technology that it's sufficient for people to want to look at it. So that's sort of where we've got to. Where it's worth having a crack at looking at it, and that's about getting the technology to that stage, and not out of the test tube, basically. Yeah.
Nice one. Thank you. Sorry, I keep refreshing slide. I don't know why I do this. Back to you, Trevor. How do we Cetogenics compete with the investment in thermal dryer assets at wastewater treatment plants recently? 25-year service life.
Yeah, no, we're modelling similar. I mean, all major engineering capital is about 20 to 25 years. So we're not anticipating any major difference. We're a thermal process as well, so we don't see any major issue with that. We've built our maintenance costs and based on the capital costs, we'll be no different than others. There are plenty of other people doing thermal drying like Canby and that thermal hydrolysis or thermal drying around the world. In that sense, it's a well-known concept of a technology, so we don't see any major issues with that.
Awesome, thank you. Final question from Slido. Should we be engaging more with community and education to build our next generation of biogas innovators?
Yes. But yeah, because it's to understand that this is an opportunity and an exciting one and one that's relevant for New Zealand, but also to educate the broader New Zealand that this is something that a lot of different farms and businesses will have a role to play. Right.
I think engaging with the community wider is required. I'm from Auckland. I don't know who else is from Auckland. I pay $78 into the council to make the food scraps collection thing happen. There's a bit of bitching and moaning about that in Auckland. But most of the people I talk to about that green bin have got no idea that it's going to Reparoa to have gas made out of it.
And I get back to something I said earlier. It's about creating champions, or at least positive awareness around what biogas is and what's happening to those feedstocks, and the fact that the digesters that you see in the countryside around Reparoa, for instance, it's a good thing. It's really positive for society, positive for New Zealand, positive for the individual in terms of energy costs.
Fantastic, thank you. Is there any questions directly from the floor? Oh, a couple. Should we go to Brian first? Because it's a special day today.
One of the things that we're talking about is access to information. One of the things the Bioenergy Association has is a library. Most of it is open to public, but a lot of it is also members only. But every report or presentation that we get and publish, I put it in the library, Bioenergy Knowledge Centre, and that is available for all of you. And it's all catalogued. You can do searches for what you want. What we're really interested in is also getting additional material. We've currently added probably 2 reports each week to the library that we get. We just steal it from anyone, and if Victor publishes something, we just take it because we know they'll lose it. And it's a repository that is there for you. We've also got all the presentations from webinars, conferences, whatever. Plus we also do webinars which are part of transferring and sharing information. And we're really keen to work with you to do more. One we've got coming up next month is on agricultural feedstocks, taking up all the reports and work that was done in the 1980s. We're just republishing it, and they're putting it into the Bioenergy Knowledge Centre. So it's an access that's there for you. It helps if you're a member, you get more access. But if you're not a member, it is that you can still use it. So, yeah.
Thanks, Brian. Question?
Can you hear me? There we go. It clicks in. So thank you so much for, the whole event's been great. I'm a regional councillor from Environment Canterbury, and I feel like this is actually a really important piece in the decarbonisation journey. But I'm also really interested, at the council, we think a lot about risk and natural hazards, and AF8 is a really key issue as well. And I'm just wondering, is anybody looking at how the sort of distributed biogas network could improve our security and energy reliability through post-major events like the Alpine Fault 8? Sorry, just to add to that, one of the things I'm thinking there is that would be a good justification for the government to get more behind and put some money into your industry, if you can link up to that.
If we come right down to the end of the chain with the appliances, Unfortunately, most modern appliances need electricity to run as well as gas. So that makes it a little bit of a challenge. Your barbecue doesn't, which is pretty important in an emergency. That's normally LPG rather than piped gas. But people that ask me about that, I say go down to Bunnings or your preferred supplier and buy yourself a 2 kilowatt generator and stick it in the garage, and that's your ultimate sort of source of security. And if then you can make some electricity, run your gas appliances if you have to. But it's ECA's fault, like everything else, because they want all our appliances to be really efficient, and we can't do that without electricity.
I guess I'm not sure I fully understood the question, but in terms of biogas, it's certainly more distributed in its production, and so that adds a little bit more resilience in the overall scheme. So that distribution is really important.
So I agree with what Paul's saying. So I think the great thing about biogas is it can be highly distributed. So we're a big fan of sort of take local waste, make local gas. Even to the point we're looking in Singapore for putting it into condominium buildings or into hospitals. So they have a highly compact system. They use their own waste, recycle it back as electricity or gas within their own buildings. And I think that ability takes away from some risk of pipeline rupture and other things that might happen with a national grid, or at least be ready to go back inside if such a thing happens and you can go local. Yeah.
I could probably speak it. Is that working? Yeah. I could probably speak as an infrastructure owner as well, and some of the work PowerCo's been doing around climate mitigation, and we've taken a pretty long and hard look at both our electricity and gas networks around the impact of climate change under certain scenarios. Increasingly, we are seeing distributed forms of energy, be it electricity generation from solar or biogas into distribution networks as a potential option to supply regions cut off by severe weather events. So, for instance, you could take Cyclone Gabrielle. During that event, we have the Hawke's Bay gas network out there. Some of the customers out there had a significant outage of electricity up to a week. They still had gas, and so they were still able to, maybe they did chuck a gen set in, but certainly we had feedback that a lot of our gas customers were still able to cook, heat their homes and have hot showers. And so certainly it is increasingly a consideration, yeah. Cool, all right. It's very quiet. Maybe my voice is too loud and that dims me down. Hey, that's great, and thank you so much for all the questions, and thank you so much to the panellists. Really, really awesome. And look, if you've got any follow-up questions, catch them at the break, because there's some really great information in these guys' heads. So thank you so much. If you join me in welcoming, not welcoming, farewelling the panellists.